Welcome to Never Rewrite. I'm Isaac Askew.
And I'm Jeffrey Sherman. And today we're going to discuss an iterative workshop that I've been working on. Workshopping the workshop.
Cool.
So at my current place, I'm helping with one of my responsibilities as a staff engineer is to help the other developers improve their coding. Mm-hmm. And I don't have a good formula or plans or tactics for how to help teach developers to write more performant code. I'm working on it, but I have no idea.
Okay.
It's like it's one of those things where it's like, oh, well, I just do the thing. It's like, okay, but how do you do the thing? So I've been working for the past month or so on what I'm calling an iterative refactoring workshop. I've taken a piece of code that is very legacy and terrible. In this case, it's a 1,000-line procedural function that no one has very limited test coverage. No one is particularly sure what exactly it's doing. Like, you could describe it at a high level. This piece of code takes a request to add a contact to an email list.
Got it, but there's no why.
There is so much, and that's okay, cool. So, in theory, that's what, 50 lines of validation, and then you add them to the list. What are the other 950 lines doing? It's like, well,
got it. Yeah,
I have no idea. And so we are working it, and I wanted to describe how we're working it because I think it's a useful methodology, and I think our listeners will possibly want to run it themselves or have some feedback and tips on it. And so I've set it up as it's not a class, right? Because it's not a class because I'm not starting at the beginning and then going to the end. Mm-hmm. But the goal is we've started with this terrible, and it's terrible because it's untestable. We started with this 1,000-line procedural, untestable code that we don't know exactly what it's doing. And at the end, we should have testable, well-understood code that is broken down into meaningful functions with meaningful variable names.
Okay.
When we're doing a pure refactor, we're not trying to change functionality per se because we don't know what it does, right? We're not trying to rewrite it or be any better. We're only trying to understand what it does and make it testable because we know there are bugs in it and we don't know what it's doing.
So is this, how did you pick this particular function that you're going to work on? Is it arbitrary, or is it an imported part that you're trying to fix?
It is semi-arbitrary. Literally, I was discussing it before I started with my manager, and she's like, oh, if you want a piece of code, here's something that is important and terrible, and I would love if you would fix it. And I said, sure, that sounds, it's 1,000 lines. That could take a while. That sounds perfect.
Yeah. Okay.
I did not do any analysis to decide that this is the optimal piece of code.
Gotcha. I have one thought on that, actually. Mm-hmm. Years ago, I think Rocco Palladino, another former colleague of ours, mm-hmm. He had showed us a method kind of similar to this, where we were using katas. I think I'm saying that right. Katas. Have you heard mm-hmm. of that term before? So
yes.
Yeah. So like the idea was that you would get something to work on, some piece of code to work on and refactor or whatever with. You would see how you'd solve that problem, and then you'd come back maybe a month later or 6 months later or something, and you do this exercise again to see how you would do it differently. And I think kata means form, which is like you're basically practicing your form over and over and over again to see how you would do it better. And it sounds like some interesting candidate here where you could, to make it practical, actually just solve, refactor the whole thing, test it, and that kind of thing. But you might also want to like take a snapshot of what it was too and keep it there. That way later you can come back and be like, hey, how would you do it now? A year later, mm-hmm. or approach people later to see if because you're trying to measure that they're doing better, that they're growing or coding more quality. So you could actually give them that kind of feedback later to show, oh, this is how you solved it last time versus this time. Can you see some improvements or something like that maybe?
That brings up an excellent point, which is I didn't describe what I'm doing. I described how it's not a class.
Oh, okay, yeah.
But we're like 5 minutes in, and I haven't even told them what I'm doing. So here's how I'm running the workshop. we've got this piece of code, right? And it's the current version of the code. And we're meeting twice a week. And I'm encouraging people, myself included, to come up with as many MRs as they would like. And you don't even need to have an MR to attend the session. But each MR should do one discrete thing that you can explain. So
okay.
as an example, this code happens to be in PHP, and the original version was in a global named function because it had been around since 2012, and that's how one did things a decade ago. And so the first thing I did is I took the entire piece of code and I created a class and I put it in the function, created a function called do everything. And I replaced the global function with just, instantiates a class and calls do everything, for the simple purpose of it's now no longer in a global function. Right. So even though I've now touched every single line because I moved it to a new file, the concept was I did one conceptual thing. I moved the giant piece of code into a class instead of a named function. And likewise, I've done a lot of other tweaks, which were like, I took this piece of code, which I know throws an exception and if we weren't catching, and I extracted into a class, into a function, and I wrapped it in a try catch block. And now I log it if it throws an error. And now, because it's not a fatal, if this piece of code throws an exception, we would want to continue on. Before we weren't. Now I've moved it to a function. Now I've wrapped in a try catch. And if it throws an exception here, we would log it and move on. And now the piece of code is more resilient.
Right.
And so every session, twice a week, we do, sometimes I have no MRs. This week I've got 2 MRs. So I hadn't had one in like 3 weeks or 3 sessions because I was busy. And so everyone is producing these MRs, and they can be small or large, but they are conceptually a single refactoring action. And the reason this is different than like a kata is if I was doing a kata, I would be doing, dozens to hundreds of these things, even in between check-ins. I do. And it's hard for somebody else to see how the sausage gets made. And this way, because each MR is a distinct conceptual refactoring step, you can see how the sausage is getting made. And you can see, and that's why I call it a workshop instead of a class, because you could jump in at any point and say, oh, here I am. I see the code. I see the change. I understand why this is a refactoring step.
So is everyone targeting, like this is getting into production? Like this is not just like a code you've extracted that you're playing around with to work on conceptually.
No,
this is actually
straight into production. Well, not straight. Within the.
Right. Yeah. Tested, I promise.
More tested than it was before.
Right. Well, I mean, like QA, you're not like just shipping it straight to production. Yeah. So how are you preventing people from like stepping on each other's toes? Like if you have like, I don't know how many people are working on this at the same time, if everyone's touching the same piece, and you're clearly breaking it apart into pieces, but they need to be sequential. That way you can show the sausage being made, so to speak. So how are you deciding who's working on which pieces at the same time?
So far, we've been small enough and the thing is large enough that people picking things randomly and working on them, we haven't had any. Yeah. It's fine. Yeah. We're meeting twice a week, and each MR is supposed to be an individual conceptual commit. So the odds of 3 to 5 people within 1,000 lines of code having something that's conflicting within the same conceptual block, pretty low, at least in the beginning.
Yeah.
Like there's a lot of MRs where it's, there were the variables L, F, and S. And so like MR was like just renamed L.
Oh, that's a good one, actually. Yeah.
Yeah. It's like, all I did is I did a global name, I used my ID and I did a replace of F to field, S to subscriber, and L to list.
Yeah, I think that's a really good method because it can be a little daunting at first, if depending on all the complexities of the function and all the weird like the globals you're talking about being used, tangled bits of code. You pull this out here, it dies because there was actually something else somewhere else it was still tied to. So like doing things like that, you're talking about extracting it, putting in a try catch first. That's it. Just move it to a class. That's it. Just rename the variables. That's it. Piece by piece by piece, and at least it's more readable, and you could even throw documents, like, or comments rather, for certain weird parts of the code that are hard to explain. Just slow, iterative.
Slow. It's much slower than if I was refactoring it myself and telling people to look at what I'm doing. So the third rule. So the first rule the third thing is, don't spend more than an hour on any MR. If you're spending more than an hour, then your step is too big.
I like that. Yeah. Or conceptually too, like, you keep your MRs like smaller than X lines. Is another good one, but that's basically another time constriction.
Because my first MR, I touched every line. It was 1,000 lines.
Oh, true. Yeah, you can't really use that rule there, can you?
Yeah. So I like the time limit concept. Like, if it's more than an hour, it's too big.
Mm-hmm.
So there's a piece of code that I hate where it's 4 if blocks deep, and then there's a for loop. And so I tried to extract the for loop into a function, and I failed. Like, I got somewhere and then I broke something, and I tried it 3 times.
Mm-hmm.
And finally I gave up, and I cleaned up the actual 4th level if statement. Was written of if var, then do nothing, else, and then the code.
Mm-hmm.
And I was like, all right, well, so after 3 MRs of like 30 minutes each that failed, the final one, the one that I actually brought to the group, was I removed the empty if block, and I just flipped it so that the else was the only thing there. And I added a comment.
Yeah, I've seen some code like that.
Just like, I bounced off. I bounced off it 3 times, and I'm like, all right, I give up for now.
Tiny pieces. It's okay.
Tiny pieces. This is better.
So, is everyone working on this by themselves, or are they pairing on this?
Mostly we are working independently, with the idea being everyone can see how everyone else is thinking about the sausage. So everyone is making small incremental MRs and explaining why they did that MR, right? How they decide.
So whenever they make the MR, they present that to the rest of the people. That way everyone can see that.
Right. So twice a week we meet and everyone presents the MRs they've done for that session, or nothing if they can. That's what helps people join in and leave out. So they present and they explain the thinking behind it, because usually the MR is very small and it's obvious. Oh, I changed these variables. Well, okay, yes, that is more clear. But why did you think that was something important?
Got it.
Yeah. And so I finding it to be very successful because I'm having people, by having it as a workshop instead of a class and having it open-ended, I'm finding people sometimes come, sometimes they get busy and they don't come for a week or 2. But because it's, everyone can come at any time, and each MR should take no more than an hour.
Mm-hmm.
People are able to find an hour once a week, every other week, and so they can come, and it encourages them to come and listen to other people talking about it and thinking about it for themselves. And so it's slow, but it's steady.
Mm-hmm.
Initially, we had the original code turned off in a feature flag. So when I moved it to a function, moved the function to a class, I actually feature flagged it. I wrapped the switch into a feature flag, and very important, I left the feature flag off. So by default, it was on the new code.
Okay.
The old code was there in case of a disaster, but I put it on the new code immediately, so that we were to say thesis shipping this. I was never not using the new code, and I had the old code as a fallback until I got rid of it after about a month.
So the feature flag was on then.
The feature flag was on. The new code was on by default, so that there was no giant wall of marching progress, and then now we're going to flip it on and see if it works. No. It was always on every change. And yes, I did cause an incident. And it was my fault.
Okay, there we go. It was your fault. What happened?
There was a Boolean that I had read as always on. This Boolean was always true. And therefore, I took it out and I collapsed an if statement. And I missed that there was a case where it was not always true.
Ooh.
And so when
That'll
it
do
should
it.
have been false, that caused an incident.
Huh. Well, at least you
Because I
know all
missed.
that code's being used.
Yeah. I mean, really, it's the reviewer's fault because I said this variable's not being used,
Yeah.
and I took it out, and they missed that I was wrong. So it's other
Uh,
people's fault.
uh,
No, it was my fault. I missed it, and I made a convincing argument that I was right, and
you are
I was wrong.
convincing.
I am good at being convincing.
Well,
But because we make so many changes and they're all incremental, it
yeah,
was very obvious what happened.
that's a great thing about it too. Instead of doing this huge refactor with a feature branch, and you have like 3,000 lines of everything being moved, you can't really review that easily. Like, wow, that's like really clean and refactored, but I can't really tell in between. So this small
Right? What
stuff
did
is
you
really
change?
nice. Yeah. Have you considered so back to my other question about like people doing it independently, have you tried any sessions as like pair or ensemble programming to kind of, you know, get people's ideas flowing in that team setting?
I have not in this particular setting. I first of all, big fan of pair programming and getting people's ideas flowing. The reason I'm not doing it here is because I'm pushing towards the asynchronous nature of it, as well as the very small incremental commits. Like an alternative way to run this would be, here's this giant block of terrible code. Let's sit together and refactor it. And we wouldn't do one change. We would probably do 50 changes. However much refactoring we could get done in an hour that made sense to us, we would do it. But it wouldn't be one conceptually distinct change. There'd be dozens.
Well, you could stipulate that. You could try to get, I mean, the only reason I say try to do pair programming is I usually just have better ideas whenever there's somebody to bounce ideas off of, kind of like the rubber duck debugging thing, where you just like, oh, so you could still like, oh, tell yourselves as a team, we're going to, work together to solve a problem, but we're not going to solve everything. Let's keep it to a few small things that we can present and not make this like, we're just trying to solve everything in one session. Generally just that people, I know a lot of people work really well independently, but I've almost in almost every case, especially for refactoring, doing the pair programming is for some reason it just sets the knowledge a bit better, especially for tricky old pieces of code that's kind of hard to like wrap your head around, because you can explain what you did to somebody, but if you actually worked in it, it kind of like sits in the memory a bit heavier for me. So it might be something you could ask around and see if they were up for it.
I think that's a key piece that you just said there was the tricky parts of the code. I feel like right now we're still in the overgrown terribleness of the code where
okay.
where it's procedural, right? This, then this, then this, then this.
Right.
It's like I don't know what any of this stuff means. Or like
you're
I don't
tackling
know
the low-hanging fruit first.
Right. It's the low-hanging fruit that's kind of obvious. And maybe, it's be like, oh, let's everyone go out there and we'll get it into rough shape independently. And then when it's time to do the delicate work, come back and pair.
Yeah, and you've already spent weeks and weeks kind of understanding the intent of the code too. So it's kind of like you're in that great context for now that we're into the meat and potatoes of the function and we know the exact context of it. Let's take a look and go from here.
Yeah.
Okay.
But I think you're right. Pair programming should be a part of it.
Cool. Well, how long do you anticipate to host the workshops? Just until it's looking pretty refactored? Is there a goal, like end goal, to make you quit?
My end goal is to host the refactoring workshop as long as developers are showing up and getting value out of it. And if we finish the code, or when we finish the code, I'll pick another piece of code. There's lots of terrible code, unfortunately.
Yep.
And so to me, the goal is I'm teaching refactoring, or I'm helping developers work their refactoring muscles, and I'm doing it in a way that adds value to the company, as opposed to, say, not to denigrate the kata idea, but like if you make a kata and then you throw it away, you've done the practice, but it didn't produce any value for the company, other than that you're now better at it. And in this way, by working on real code, we provide value as well as the training.
Right. Yeah. I mean, if you're going to work on your skills, it makes sense to at least target all that extra efforts towards really bad or really in need of rewriting code, or just areas that are really impactful, or just pervasive bugs that are super frustrating that you keep putting on the backlog to fix and never get around to.
Right.
Yeah.
In this case, we don't know of any pervasive bugs. There probably are, but the code is so untestable we don't know about them. What we're working on is the pervasive failures. So, it's a cloud-based thing. You're going to have occasional database failures. You're going to have occasional disk failures. By simply wrapping things with a try-catch and continuing on with, it's like, okay, if this fails, do I need to abort the whole process? No. Okay, cool. Then I'm going to continue on. And at scale, if this piece of code probably runs 1 million times a day, those try-catches are probably saving dozens to hundreds of random failures.
Right.
Not a huge amount, but it's that low-hanging background noise of stuff, and just making it a little quieter.
Yeah. And then teaching people to find other areas and keep doing the same.
Right.
Everything starts humming a bit better.
Yeah. The tuning, right? I think that's it. Let's maybe summarize.
Yeah.
All right. So what I'm doing is a workshop, meeting twice a week, but your cadence could vary. We've taken a specific chunk of bad code, and bad in our case means it's untestable. And we're meeting twice a week, and we are doing independently, we are doing MRs that are each an hour or less, and each are a distinct conceptual refactoring idea. So I'm going to rename these variables because they're unclear, or I'm going to surround this with a try-catch because this is a survivable error if it fails. Developers can have as many MRs as they want every time, or they could have no MRs. And then when you meet, everyone who's got an MR meets to explains the concept behind what they're doing. The code is usually pretty self-explanatory, so it's not that important because these are small individual refactorings. So it's nothing changed, and it's just why I thought this was a good thing to do, or like why it occurred to me at this time. And then the code goes into production in the regular cadence of how our code goes into production. The MRs get merged, and then it's in the next release, and it's out there in production, which means that, yes, occasionally you're probably going to cause a bug, but because you're doing this incrementally, it's going to be obvious where you did it. Whereas if we were working on a branch and we made all these changes and we tried to merge it all at once, but the bugs would still be there. But there'd probably be more than one, and it wouldn't be easy to find.
Got it. And also that it's feature flagged so that you can quickly disable it in case something goes wrong.
Yes. Well, I removed that after about a month because, and I've had this happen to me in the past. I've been doing this exact thing, and then something changes, and somebody doesn't realize that there's a feature flag surrounding the original code, and they modify the original code.
Oh.
They don't modify the new code, and now you're trying to keep two versions in sync.
Yep, got it.
So, after a little
feature
bit,
flags. Short-lived feature flags.
Yeah, your feature flag to the original code has to be short-lived, and then if you're still want to be very cautious, reapply the feature flag to wherever blocks you're changing that release, and then remove them in the next release.
Awesome. I like this. I like the idea of the workshop. Might try to implement something like that here.
Yeah, very lightweight. I think it's been very helpful, and I hope it is helpful to you. Anyway, thanks for listening. I'm Jeffrey Sherman.
And I'm Isaac Askew, and this is Never Rewrite.